Okay, so in this equation, now we're looking at a polynomial. I count 1 right here, 2, and 3 roots. So this is at least a degree 3 polynomial. And so I'm going to have at least 3 factors that I need to consider, and I'm going to use the method I used on the quadratic roots exactly the same. We know we want a degree 3, so we should have 3 x's total. So this first one from my 0 would be x plus 8. Again, that's the opposite of 0 product property. So if negative 8 is our actual root, then x plus 8 is our factor. Then we want to look at our second root over here. This is negative 1, so that means that x plus 1 is our root there. And then we have our third, notice we have a quadratic now. See, our red line is a quadratic because we currently have 2 roots. So you notice when I type in the first root, we have a linear function. When I type in the second one, we get a quadratic function. And then when I type in this third root, which is positive 5, so that'll be an x minus 5, now I get my cubic function. Again, we're going to just use the roots where it's crossing the x-axis and factored form to write the equations of these polynomials. Let's go to the next one. Okay, if we have something like this that bounces, remember that counts as 2. That is 2 roots right there. So we need to take into account that double root or that square root and make sure we square the factor that represents that point right there. So starting on the left, we have a negative 7, 0. So the factor there would be x plus 7. Again, notice I have a linear function now. And then this is a positive 2, so that means we're going to have x minus 2 as my function there. But notice now I have a quadratic, and I don't have any other roots, so I need to remind myself that I need to square this one because it's a double root. It's a bounce point, we call it. It comes down, hits the axis, bounce back up, so it counts twice, just like a quadratic would when it's on the x-axis. It's a double root.